Okay, hello. Um, just been given this question and I have to quickly run it through and see how I can work it out. Right, it's a electric circuit. I don't know which grade, but I think it's grade 12 since I see there's internal resistance. Question 8. So in the circuit diagram below, resistors are connected in parallel as well as in series. The battery has an EMF of 24 volts and an internal resistance of 1 ohm. When switch S1 is closed, the reading on the voltmeter V1 is 21 volts. Uh, I want to get to the part of calculations. So I'll skip 8.1, which is something I don't usually do. Right. What's the first thing that I do when I'm given a electric circuit? Scatter all the information given, find out if there's any unknowns in the electric circuit. Right. In this circuit, I'll have to redraw it now without the connection of S2. So when I redraw it without the connection of S2, it'll look something like this. That's the internal resistance. And then this goes down to S1. This is V1. Right. And there is this 3 ohm resistor. Okay. Then there's that parallel part of which I said we are going to not include the part that has S2 with the 5 ohm resistor because I didn't get the full question there. So when it comes to parallel, I like to use color coding to show that there is current um, that is being split up. Right, then they can take green for resistor R. And I can take white for voltmeter V2. All right, I think it looks something like this. Okay, now filling in the information. Given an EMF of 24, EMF is E, it's 24 volts. There is R internal, I'll call it R int, which is 1 ohm. And there is the velocity V1, which is the potential difference, which I call V external. So V external has been given as 21 volts, right? Now, what do we do with such information? first thing I can do is to calculate total current. I can literally calculate the total current with all of this. How do we calculate the total current? We have a formula that says E is equals to I total R external plus R internal. Or it says E is equals to V external plus V internal. Okay, sorry about that. I had to check on the question from another phone. All right, now we are given E, we're given R internal, we're given V external. So it means we can use this formula now that says E is equals to V external plus V internal. This is 24 is equals to 21 plus V internal. And thus it will give us V internal of 3 volts. And V internal is equals to I total times R internal. Now V internal is 3 volts, I total we don't know, and R internal we know it's 1, such that the total current will be 3 amperes. So to go back to our first question in calculations that says the reading in V2, calculate the reading in V2. Now V2 measures the voltage that passes through the blue resistors and the green resistor, of which it's resistor R and the two resistors with 4 and 2 ohms. So this one is the 4 and the 2 ohm. So it's measuring the voltage that's dissipated between those two parallel resistors. And the question is asking us, what is the reading at V2? So voltage external. The voltage external can be split up amongst the resistors in series, which means this part, the parallel resistors are in series with the 3 ohm. So you'll have voltage here and you'll have voltage here. That makes up V external. Right. So now we go back here to say V external is equals to V of the parallel resistors plus V of the 3 ohm. And with that formula, we can simply calculate V of the 3 ohm by saying this is I total times 3 ohm. And we know I total is what? It's 3. I multiply by 3 and we get 9. We know V external as well. V external we are given as 21. So V external is equals to 21 volts, but we know that V external is equals to V of the parallel resistors plus V of the 3 ohm. This is 21. We don't know V of parallel, which is what we're looking for as V2. So we can simply write this as V2 instead of V of parallel. Sorry, V2 plus the one we just calculated, V of 3 ohm, it's 9. And when we calculate our V2, we find that V2 is equal to 21 minus 9, that'll be 12 volts. Right. The 12 volts, you can go back here. For resistors that are parallel, they have the same voltage, meaning this is 12 volts and R is also having 12 volts. But as I said, this combined, meaning 4 plus the 6, will have the 12 volts being dissipated by the batteries. Right. The next question is asking us about the power dissipated by the resistor R. What do we know about resistor R? We just said it now that we now know the voltage. So about resistor R, the voltage is 12 volt. We want its power. We don't know its current. We don't know its resistance. So we need one of these two. And which one would be easier? So I decided to go on with current. Why? Remember I said I'm using color coding here for blue and green to show that current is being split up here. So when that 3 ohm is coming here, it's coming throughout here. Gets here, it's split. Right? When that happens, we can calculate the current that is passing through the 4 ohm and 2 ohm resistor. Okay, and if we know that, we will know that from 3, what is split to the blue and what is split to the green. So let's try and calculate that. I will leave this as it is and just try and scroll up. Alright, we have 4 ohm and 2 ohm, which are in series. Therefore, we can say their resistance is what? The resistance of 4 plus 2 is just 4 plus 2, which is 6 ohm. Therefore, they have a voltage of given by IR of this 4 plus 2. Their voltage is 12, which is equal to the current and their 6 ohm. Therefore, their current is equal to 2 amperes. Now, since this is 2 amperes, the current coming in totally gets split up to green and blue. Now, I blue, sorry for the name calling, plus I green will be equal to 2A. This is 3A, and you get I green. Mathematically, I green will be equal to, you can call it I green or I of R, as long as you've correctly indicated, will just be 1 amperes. Now, for the resistor R, sorry about that. For the resistor R, we now know the current, of which is 1 amperes. So we can therefore use the formula P is equals to VI, if I remember correctly. P is equals to VI, and that is 12 volts multiplied by 1, which is equals to 12 watts. And there we have our power dissipated. Thank you.